Thank you all for being here. Thanks for the opportunity for me to speak on this topic today. So my talk is going to be about open source match analysis tools for scientific computing. And as Joris already mentioned, I'm from the German Sports University Cologne. I started my bachelor's and my master's there starting in 2014. And starting in 2021, I started my PhD there on the topic of automatic match analysis of invasion games with position data. So during the last 4 years, I was mainly sitting in my little office in this little building right on this campus, and was part on multiple projects, answering multiple research questions, dealing with various data sources from position data, but also event data, and different kinds of metadata from different sports. And very frequently I came across varying challenges within this research area, basically reoccurred every time we conducted a study. And the first challenge is that we're dealing with quite complex and heterogeneous data. So data comes in different formats, it comes in different volumes, it comes by different providers, in different granularities and different modalities. So we have event data, position data, video data, and this is quite complex to deal with when you start working with this data. Secondly, there is not really a common data pool in this area of research, so everybody simply does science on whatever data they can get their hands on. This could be 1 or 2 matches from an amateur league, or some experimental data, or thousands of matches from top 5 European leagues. Anywhere in between that, there are studies published on this. And third, if you're starting as a newcomer, as a new researcher, without a coding background, getting into this area is quite challenging. Like all of a sudden, you have to figure out coordinate systems, you have to figure out signal treatment, trigonometry, filtering algorithms, and that's even before you can start doing some real analysis. And I think what I would like to say, symptoms of those challenges, they show all over the research field. And I give you now 3 examples from the literature where I think those symptoms show really well. So I want to start by this scoping review by Susan Ellens that was published in 2022. And what they did is they reviewed 276 papers that reported some sort of metrics with accelerations or decelerations. So every time a paper did, I don't know, time spent in acceleration zone or number of high acceleration events, what they did is they extracted the methods used for deriving the acceleration and decelerations, but also the data treatment methods used before even analyzing the data. I want to have a quick look at what they extracted here. So these are the techniques to clean the data, the raw data, before actually deriving the accelerations from it. So we have moving average filters or median filters, some more advanced polynomial filters and exponential filters in there for some of the articles. And I want to maybe play a quick guessing game and see if some of you guys can guess the most frequently used filtering methods today in the literature about accelerations. The Kalman filter, okay. Any other filters come to mind that are not already on this list? Okay, if not, the Kalman filter unfortunately is not on the list. But I think you may be all aware of the Butterworth filter. So that's a spectral filter that's very frequently used. That's the second most used filter in that list. So the third most used filter is this nice filter called the unspecified manufacturer's filter. Yeah, by far most frequently used. So you can see they had to break the x-axis here to even make the bar is no data cleaning technique specified. And I think that's a very crucial thing to see in the literature, because that means that not only you as a reader, you don't know what data cleaning was done before deriving accelerations and decelerations in the vast majority of studies, but I think it's fair to assume that not even the authors know what data cleaning methods they use to do that. For the second symptom, I brought a quote from Matt Harrell from his review in the International Journal of Sports Science and Coaching. I'm quickly going to read that to you. So from a method standpoint, early research studies rarely validated their results with a test sample, and several research studies had relatively small samples, so only 1 or 2 games. With some exceptions, more recent studies have improved upon this and provided descriptions of the method that allow for rebuilding their model and redoing the analysis. In doing so, practitioners can be sure that those approaches can be applied to new data sets and hold some predictive value rather than overfitting the data to show promising results within a publication. So I think what Harold and colleagues really want to state here is that within every research paper, the authors should show that their results not only hold true within their own study, so the data they use for the study, but they should apply their model to some data outside of the study and present that their results are also valid outside. And as a third symptom, this is something from my rather personal collection. So this is a study that was sent to me for peer review. And the authors reported some acceleration metric. They summed up the axis of the accelerometer and reported results on this on lacrosse goalkeepers. And they provided a reasoning for that goes, although these metrics have not been reported to quantify the external load of lacrosse goalies, they have been used in rugby and were chosen based on manufacturer's recommendation. And I really like this quote, although it's not really public out there, but it's a really honest quote. And I think if researchers were more honest about what they're actually doing, then we would find quotes like this way more often in the literature out there. However, unfortunately, any manufacturer's recommendation cannot be a valid reason for using any metrics whatsoever, how valid they may be. So I think the problems we are facing currently in the literature is that we have first an issue of transparency in methods. Second, we have an issue of the transparency in data those methods are applied to. And third, we have a lack of culture where we only accept as research and evidence where the former two are actually applied. So in this talk, I want to give you 3 approaches that we did in our previous work in our lab, where we try then tackle those problems from a scientific perspective. So first, I want to start with the methods and Floodlight. So Floodlight is an open source software package, and it started in 2021 as a project under the lead of Dominik Rabe. And we wanted to build a framework for data-driven sports analytics. So we came to the realization that we have this huge amount of heterogeneous data. We have a large overhead of programming for each project that we are doing. And we don't really see any reporting of methods within the scientific field. So we want to build this project to aid researchers and to help them along the steps of data analysis. For that, we included data parsers and access to public data sets, data transformations and visualizations, access to scientific models, and also accessibility through documentation and tutorials. So starting with data parsers, we have lots of parsers built in here for major data formats. So for example, Stats Perform and Opta is built into the parsers. And also we are trying to build API interfaces so you could actually access the data directly from your provider. We then add very early methods for transformations. So the stuff you have to do before you can actually work with the data, slicing it into segments, translations to different coordinate systems, rotating the data, scaling it up and down. But also the filtering methods, the smoothing methods that I described earlier, we have them included out of the box already in Floodlight. We have visualization techniques, so the visualization of football pitch and also other sports, and also for the trajectories and the coordinates of the players. And since we're built upon packages like matplotlib and numpy and pandas, it's fairly easy to customize the plots with matplotlib, and we are also compatible with packages like Seaborn, so it's super easy to do visualizations like kernel density plots or heat maps. We fairly emphasize about models that we include, and every model that we include in Floodlight is, I would say, a scientific model. What that means is that it has been published within a scientific journal, so it has gone through the quality control of peer review So our models right now contain calculation of distance and speeds and accelerations, but also more complex approaches to player load modeling, so the metabolic power model. But we also go into technical analysis, so metrics from the collective behavior like team centroid, convex hull, distance to nearest neighbor, distance to nearest opponent, and also metrics from the ecological dynamics like approximate entropy. For space control, we currently have the Voronoi approach implemented, and wherever it's appropriate, we also have visualization techniques for our models for you to present some nice, colorful presentations. And what's very important for us is that all of this is very easy to access for everyone. So, of course, we are fully open source. You can find us on GitHub. The package is available via pip. And our documentation is available on Read the Docs, along with extensive getting started and tutorials with workshop material, a compendium that explains our design choices. And yeah, every method, every function is explained in detail, so you know what exactly it does. So we are currently, I would say, a rather small group of active contributors, but we're looking forward to grow in this community, and maybe in the future we try to provide you with open source tools to do analysis like this, like we just published in a paper last year. Okay, so let's go on and look at the data part of this talk. I think most of you, as I saw in your badges, you're basically working for a club or something like along those lines. So maybe you don't really have an issue with getting data, but if you're working in research or if you're a newcomer to this field, this is not necessarily the case. And there are reasons for limited data availability. So generally data generation is very costly, and data providers, they need to sell their data also as a product. So they can't really give too much of the data away, otherwise they would lose an economic edge. Secondly, data contains information, so other owners of the data like leagues or clubs, they also don't really, they really want to keep their data to themselves, because otherwise they're afraid to lose a performance edge over the competition. So pretty much every data owner, they feel some or the other disadvantage if they share too much of their data. But there have been some endeavors. For example, I think within the Opta forum last year, StatsPerform published a sample data set from their tracking and event data. Our research group recently published a data set of events and position data in Handball. I'll come to this in a moment. But this high quality event and position data, especially that's officially provided by the clubs, by the leagues to the clubs, is really, really rare out there. Due to that reason, my group reached out to the German Football League last year, and we asked them if they could provide us with a data set that we could give to the public as an educational resource and as a benchmark data set. And fortunately, I wouldn't speak about that if that wasn't the case. They agreed to that. So they provided us with 7 full matches of the first and second Bundesliga. These are the matches that we got from them from the season 2022-23. And it's the full official position data, fully raw, nothing applied to them, over 11,000 events, also from the DFL, and all of that is published under Creative Commons. So it's basically for you to use it however you see fit. And the only thing that we ask is that you acknowledge us and the paper when you do so. So in this paper, we provide some examples on what we think people could do with this data, if you don't have any ideas already. So for example, evaluation of expected goals models. What we did here is simply plot all the shots taken in this data set. And the red markers are the shots missed, the green markers are the shots scored, and the saturation of the markers are the respective expected goals values. And a simple plot like this already shows, like, okay, the shots more adjacent to the goal, maybe the ones with more or with higher expected goals, but this is not necessarily the case, so there are other contributing factors. A different idea for use case would be data synchronization techniques. So this is a big issue. Every time you're working with event and position data, you want both sources synchronized. And for this data set, we applied a step to this by the guys from KU Leuven, from Michael van Rooij, the ETSI approach, and we evaluated those results both temporally and spatially. So first of all, on the left, you can see the temporal evaluation. So it's just a distribution of differences between the original timestamp in the event data and the synchronized timestamp in the event data. And you can see that we corrected those timestamps by roughly plus minus 5 seconds. And to see if this correction actually resulted in higher quality of this data, we evaluated the spatial error of those events. So in the middle and the right, you can see the difference between the x and y coordinates, between the position data flag within the event data and the ball position at the timestamp of the position data. And in the middle, you can see this for the unsynchronized event data, and at the right you can see the same for the synchronized event data, and you see that this synchronization step worked really well in reducing the variance within the spatial error. But I think personally there are way more use cases than that. So for example, evaluation of space control models, or also trajectory clustering, for example, for formation recognition, or network analysis for passing networks. So basically every time you see a plot like this in a publication, there should be no reason why there's no raw results on those methods reported on a public data set out there. And with that being said, I want to come to the culture, and I'm going to, for this part, diverge a bit from soccer and go towards handball. And I think you guys can bear that, although I know this is a conference on soccer data. But I want to show you our approach, like a very simple approach to make this available, or culture in research. So in handball, we also have position data. It gets tracked by a local positioning system. But one thing we don't get is any sorts of flags within the data. So we don't have a possession flag. We don't have a ball activity flag. This is something that you often get in football data. And this provides quite a challenge to researchers. What researchers now usually do is they report metrics for some arbitrary time sequences. So like, for example, when we look at distances covered of the players, then the distance covered gets reported for whole matches or halves or 10-minute segments. So any arbitrary type of segment that holds no real semantic value. And we think this is quite the problem, because it overlooks the underlying dynamics of the game. So our goal was to build a pipeline that only uses this position data, and we want to extract ball possession phases based on this position data and fully automatically. So no human annotations in between, but simply an end-to-end pipeline. And we wanted to do that for the smallest sensible segments, and that's the ball possession phases. We then further want to classify the ball possession phases into either counterattacks or position attacks, to then further be able to do a really large-scale data analysis in handball based on this contextualized positional data. So what did we do? We started with 10 matches that we curated with domain experts, and we labeled them into either ball possession phases in counterattacks or position attacks. And we split those 10 matches into 8 training matches and 2 test and validation matches. And we trained a graph neural network to be able to classify frame by frame those matches into 5 classes. So it's either the counterattacks of team A, counterattacks of team B, position attacks of team A, position attacks of team B, and everything else was classified in an inactive phase. So whenever there was some interruption in the game, that was counted as inactive. And for the results, we reported all the necessary classification metrics. So we got a confusion matrix where you can see for some classes this worked quite well. Other classes got confused, for example, with the inactive phase. We reported the precision and the recall and F1 values. So all the necessary stuff was in here. And also balanced accuracy of 86.3%, which is 86.3%. But I think from a practical perspective, all of this information that is reported in the paper, it gives you no intuitive idea on how well we actually solve this problem. And we saw that in this publication, and we said, okay, we got to improve on that. If we want to convince people that this is something that works, we got to show them how it works. We used the public data set that I mentioned earlier. It's the Events in Invasion Games data set published by Henrik Biermann, who's also here in the audience today. And this data set comes with 125 minutes of raw position data and video data. So we simply applied this method of extracting the possession phases to the raw data. And since we have the videos as well, we were able to not only publish raw classification results, but also human-readable crop marks. And I went ahead and took one match, this isn't cherry-picked, and just extracted those clips from the video data. So you can start here. This is a possession attack from Team A, and it's just the usual handball match. I think it's fairly early in the match, so I'm not pressing that hard. Just in a second, he's going to attempt on target, and right here the classifier says, okay, this is the end of the position attack, because the attacker now attempts on target. So the next thing that happens is an inactive phase, and this is due to the reason that whenever a goalkeeper in handball holds the ball, this officially counts as inactive. The game is interrupted during that time. So now the goalkeeper has the ball and he throws the ball to his teammates, and the next phase that happens is a counter-attack, and you can see that the attacker is pressing the defense up until here, and right now you can see here the defense is now organized within a defensive structure around the box. So the classifier says the counter-attack ends here, and it transverses into a position attack. That's actually quite short because this guy thinks he can make it through and score. And here the position attack again ends. And the next thing that happens, let's see if he scores. Yes, he does. This is now an inactive phase, so we can see the attacking players are now maybe substituting or catching a breath, but they're not pressing the attack, so for us that means it's inactive. So I think looking at these examples from the video gives the user a way more intuitive feeling on how well we solved the problem, and I think from a domain perspective, I'm pretty confident that whatever 86.3% accuracy means, this is a quite good segmentation of the match. So to conclude, we heard about 3 topics today: the methods, the data, and the culture. And I want to give you 3 take-home messages. The first one being open source empowers. So open source of methods really enables researchers and newcomers and everybody in the field to make progress in the scientific domain. Second, standardization matters. So standardization of to what data we apply those methods helps us to make comparisons between data sets, between methods, and even between sports. And finally, fostering this as a culture, fostering this within this community, and only accepting new proposals where the aforementioned criteria are met should be accepted as new evidence in the field. So with that, I have some references. I leave that slide for the recording for a few seconds. That being said, thanks a lot for your attention, and I hope we can discuss this further later in the meetup.